Alright guys, so in this video we are going to be looking at orders of reaction. Please, I want to let you know that orders of reaction actually stems from the topic chemical kinetics, and you know chemical kinetics have to do with the rates of chemical reactions. Alright, the rate at which the reaction proceeds from the reactant side to the product side. Alright, but then for orders of reaction focuses on the power or the exponent in which the concentration of the reacting species in a given chemical reaction is raised to. All right, so we have three orders of reaction. We have the zero order reaction, okay, we have the first order reaction, and we have the second order reaction. Now, I want to let you know that generally in a reaction, the concentration matters a lot as it concerns the rate of the reaction. So concentration is a very huge determinant or a very huge factor that affects the rate of a reaction. Now, I want to let you know that for zero order reaction is actually when the concentration is raised to the power of 0. But now, basically, in a zero order reaction, the zero order reaction is telling us that the concentration is not actually influenced by the rate of the reaction, neither is the rate of the reaction influenced by the concentration. All right, so what it means is that the rate of the reaction does not depend on the concentration of the reacting species in a zero order reaction. All right, so now the zero order reaction is actually giving us your AT, which is your final concentration, equals to your A naught minus K naught T. Now, this K naught you're seeing here is your rate constant for the zero order reaction. Your A naught is your initial concentration. Your AT is your final concentration. I want to let you know that initial concentration and final concentration are both measured in mole per dm cube, mole per liter, or molar. All of these mean the same thing. Now, the unit for your rate constant is mole per liter per second. That in fact is from the rate constant from the unit that you actually know the rate of the reaction, the order of the reaction rather, in the particular question. Now, for first order reaction is actually giving us log AT equals to log A naught minus KT all over 2.303. This is the formula. Now, why the unit is just per second? For a second order reaction, the formula is 1 all over AT equal to 1 all over A naught, okay, plus K2T. Now, why the unit is mole per mole dm cube then per second. This is the unit for that of what's it called, second order reaction. Now, there's what we call half-life. Half-life is the time that is taken for the concentration of the reactants to be reduced to half its initial value. So the time that it will take the concentration to be reduced is what we call half-life, and it's measured in seconds. Now, for a zero order reaction, the half-life T1 over 2, this is what is denoted as, is equal to your initial concentration all over 2K. For first order, your T1 over 2 is 0.693 all over K. While for second order, T1 over 2 is 1 all over K A naught. So these are the formulas. So please take note of them.